Hi, today I'll be introducing to you the Robotic Modeling VI. We can get started by running it. Once we run it, you'll be able to see that it automatically populates the X and Z plane coordinates. This is a preset initial value that determines which state that runs the VI according to these stages of the shelves. So once we run that, you'll be able to see the robot going to the bottom floor, the first shelf, the second shelf, and then the third shelf. You can then see the stages running as it runs through it on the right hand corner here of the status. You can initialize the values as a preset values, or you can then modify these values if you turn that initializer off to your own values as you wish. Once you click to run, the status will reinitialize, and you'll be able to see the robot performing your own modified values. Let's finish that out. As you see, it ran through those two as well. Now, once you can also go to the stage selector, and here you'll be able to determine which one you want through. If you run the floor, as you can see, you'll go to home position and down to the floor and grab the object. You can then place it on a third shelf if you wish, or any other selection. You can modify the resolution per cycle, similar with the simulation. If you have it 1000, that means the projection will be 1000 split from the start position to the end position. That means the robot will run slower, but also with the smoother pattern. As you can see, it won't click, kind of jump. You can modify that to lower values as well if you wish. Let's say you have that 100, let's do 50. Once you run that, you can see it kind of jumps between the places. I kind of personally like the 200 state. You can manually drag the robot. If you go to the X, you can see the X coordinate. You can do the same for the Z, the Y, and then you can modify the pitch as well of the end effector. Now let's have a look at the actual code. In the block diagram, you can see that we initialize the code, and here we have the DV parameters. It then goes through an initializer, then initialize the robot drawing. You can actually see that. If we go there, you can see initializes the plot. Then we have the margin jogging state, the stage selector, and we also have the simulation stage. Let's have a look at the selector stage. In the selector, we have the following. In here, you'll be able to see the first shelf, second, third, and the fourth shelf, all with its own parameters of X and Z coordinates predefined. As you can see, determines the position. These coordinates is passed on to the sub-VI with the current position, as well as the references and any other links that's required to run the VI. Let's have a look at the actual VI. Let's close that. Don't need that. Show block diagram. Let's open that up. Let's start with this. So in here, this is where all the coordinates gets passed through. It auto indexes it into the for loop. The for loop then takes each position of that one and passes it on to this index array, which then splits by X and Z coordinates. It passes on to the sub-VI. The sub-VI mainly gets the value of X, Y, Z in the translation, and the X, Y, Z of the rotation, and converts that into transform of the end effector. It then gets passed on to the trajectory builder. the current position is also calculated and then passed on as a transform format to the trajectory. So then you have the start and you have the end position, where the start is always its current position and the end it's always where it's planning to go. This passes on a trajectory of points to the inverse kinematics calculator. To the inverse kinematics VI auto calculates the trajectory in bulk. It doesn't calculate, it can calculate one separate, but in this case it's calculating all at once. This will prevent any jogging between points of the calculation, and then calculates to have a smooth pattern. In here we have the masking. In this case we are only looking at the x, y, z of the transform in the transform x, y, z for the translation, and the y for the rotation, in this case the pitch. It passes that on. We then have the maximum steps, in this case how many iterations the inverse kinematic is going to go through. In this case, those trajectory gets passed on to the for loop. The for loop then auto-index each of the trajectories and updates the robot with the trajectories. In this one here, the value gets passed on to this reference point, where the reference it actually refers to the visualizer, and it auto updates according to the loop. For the statistics box, the values get initialized in this point. What it simply does is takes the array size from this, then passes that into the array initializer, where it initializes all the value as false, and then saves that into the reference, in this case the actual tick boxes. So he updates those all to false, then he passes those on through the sequence. Once this stage is completed, it then runs through the write bit. That means it makes sure that he only writes if he writes ever to this point. What he then does is writes those according to its current iteration on, in this case here, its current position through the loop. It then writes that into it simply, and then passes that array over through the shift register, so that it then updates the second stage accordingly. In the manual jogging stage, we have the x, y, z and the pitch values from the sliders in the front panel passed on to the transformer EI. This gives out outputs the transform or the end effector. The end effector, that this is then calculated in the inverse kinematics, again using the 100,000 maximum steps, and then that's auto given to the robotic arm visualizer update. Going back to the main RBI, in the selector state, as it goes past, it then updates the value for the x, y, z coordinates in the manual jogging. This means that any position that it ends up in, the manual jogging will auto-populate that into it and make it its current position. So it basically auto-populates current position to the manual jogging tab. Now let's have a look at the simulation. The VI is the same. In this case here, all the stages are passed through this XZ plane coordinates, which are basically these if initialized. If not, it is using the one that it's on the front panel. Takes those into the sub VI, again the same sub VI as previously described, and the sub VI outputs the current position, and that current position is also updated into the manual jogging. So the manual jogging will always have its current position for the sub-PI. In the manual jogging stage, the XYZ plane and the pitch is passed on to the transform, to this transform VI, which outputs a transform for the XYZ plane. This then it calculates the inverse kinematics and then passes on the current position for all the joints to its current position stage, and then updates the robot, and then it then passes on to the visualizer.